All right, good morning. Time to try another lesson here. This is coordinate proof, okay? So you should open your books to page 666. Don't get scared, okay, about 666. We'll just be there for a moment, okay? So open your books to page 666, coordinate proof, all right? About 3/4 of the way down the page is your infamous little brown box, okay? It has the guidelines for placing figures on a coordinate plane, all right? So I want you to copy that little brown box into your notes, and then we'll talk about it, okay? And again, obviously, you can pause right here and copy it in your notes, and then when you're ready to resume, you can go back to playing, and I'll be talking. All right, so you should have it copied by now, so let's talk about it. So these are guidelines. They're not rules. They're not laws. They're guidelines. They're suggestions, okay, about how you're going to do coordinate. Proof has to do with how do we put figures on a coordinate plane is the basic idea, okay? How do I put figures on a coordinate plane if I'm going to do a coordinate proof? Don't get too much worried about that. This will be a short lesson, short assignment. So first thing is use the origin as a vertex or a center. If I use the origin, then the coordinates of the origin are 0 and 0. So those are nice, easy numbers. So that's either going to be like a vertex of a triangle or something, whatever, or it could be the center. If it's the center, then I can go symmetrical up, symmetrical down, symmetrical right, left. The second suggestion is put at least one side of a polygon on an axis. If you put it on an axis, either this one or this one, then you're, again, minimizing your different points. You're trying to use as few letters as possible. The third one you should have written is keep the figure within the first quadrant. If you keep the figure within the first quadrant, then all your numbers and letters are positive. Okay? They're positive or they're 0. That's simple. And the fourth one is use coordinates that make computations as simple as possible. That's the idea. I want to use the least number of, I want to use as many zeros as possible and use the least number of letters as possible, which means I would rather use A and negative A than use A and B, okay? So again, there's no correct answer how to do this. There's varying answers, all right? So we'll just go to the assignment, okay? Our assignment is homework number 12, which for regulars is 12 through 19. Sorry for honors. You honors guys, that's 12 through 21 on pages 669 and 670. Okay, so write that assignment down. It's going to be in RenWeb, and it's also going to be in Google Classroom, so you don't have to have it written down, but that's not a bad idea. All right, so that's basically the assignment, homework number 12. Okay. All right, so let's look at 12 through 15. It says name the missing coordinates in terms of the given variables, okay? So for number 12, we have an isosceles trapezoid, okay? All right, and so this is K, L, and N, okay? And it's isosceles, which means it's a trapezoid, which means this is parallel to this. Make sure you draw the picture. I expect to see the picture there drawn, okay? This is, of course, the x-axis and the y-axis. And so this is the origin. And so this point over K has the coordinates. Well, we don't know. We got to figure that out. We'll come back to that, okay? So for L has the coordinates A plus B and 0 because it does lie on the x-axis, okay? And point M has the coordinates A and C. And this says, again, we don't know what these coordinates are, okay? Question mark again here. So we want to find the coordinates for point K and N. All right, so let's look at N. Let's do N first, all right? First off, since it is on the y-axis, then obviously it has an x value of 0, correct? And if this is parallel to this, then that means that this y-coordinate C also has to be the y-coordinate over here. So my answer is 0 and C. That's pretty simple, right? All right, let's look at K. All right, K is down here. It's on the x-axis, so therefore, obviously, it has a y value of 0, okay? All right, so if this is isosceles and this is congruent to this, which means the distance from here to here has to be the same as the distance from here to here. All right, the distance from here to here is A, and the distance from here to here is A plus B, so that must mean this thing right here is B, okay? The distance from here to here is B, so the distance from here to here is B, so this coordinate has to be negative B, all right? That's how you would do number 12. All right, I'm gonna erase mine while you're getting set up for number 13. Again, you can pause. It's a nice thing about the video. You can control the speed here. All right, 13. X and Y. And we have a triangle, okay? And it says triangle DEF is isosceles. So triangle DEF is isosceles, which means this is congruent to this, okay? All right, so point E has the coordinates A and 0. And D we don't know. And F we don't know, okay? All right, so F is isosceles and this is congruent to this, and this is also congruent to this. That means if this is A, then this has to be negative A. So point D has the coordinates negative A and obviously 0 because it lies on the axis. So point D is negative A and 0. So what about F? Well, F is on the y-axis, so it must have a 0x, and it doesn't have names, so let's just stick in B and let's just call it B. All right, or whatever you want to call it. All right, so that's number 13. Okay, again, email me with your questions, okay? All right, so I'm going to erase. You guys can pause if you want to. Stay with me, whichever way you want to do. Anytime you feel behind, just pause, okay? All right, 14. 14 is a parallelogram, okay? So that means this is congruent to this, and this is congruent to that, and this is parallel to this, and this is parallel to that. Make sure you're drawing this all in your figure. I'm going to be looking for it when I grade your papers. Okay? All right, so point P is right here. Point P obviously has the coordinates 0 and 0, okay? Point Q, we don't know. That's the one we've got to find. Point R is here. Point R is A minus B and C. And then point S over here, we don't know, okay? All right, so this says A minus B. So I assume that means that this is A, okay? All right, so from here to here is A, and this must be, so this is A, and from here to here is B, all right? And if this is C right here, then this also has to be C over here. And this distance here, if this is B, this has to be negative B. So point S has the coordinates of negative B, because we're going this way, the same distance as here, and C, because it has to be the same as that. So S is negative B and C. Q, we're looking for, and Q, obviously, we said it has to be A, and it has to be 0 because it lies on the x-axis. So that's fairly simple, okay? Again, get caught up. When you're caught up, continue the video. I'm going to erase. And go to 15, sorry. All right, A, B, C, D, E, F is a regular hexagon. So this is A, B, C, D, E, F. Well, it's a regular hexagon, 1, 2, 3, 4, 5, 6 sides. and all of those sides are congruent by the definition of regular. Okay? So point A is negative A and 0. So point B must be what? Must be positive A and 0, okay? Point C is B and C. Point D, we don't know. Point E is negative A and D. And point F, we don't know. All right, so if this is A and 0, if it's regular, this also has to be A, all right? And it has to be D because it's parallel. It has to be A and D, okay? This is negative A and D, this is positive A and D. This is B and C, though this must be what? This must be negative B and C. So not that difficult, all right? All right, get that written down, look it up. Well, I ignore my wife's phone ringing. All right, turn to the next page, page 670. 16 through 19 says prove using coordinate proof. Okay, again, we haven't done a lot of proofs in geometry, but this is about algebra. Okay, coordinate proofs, and this is fairly easy. All right, so number 16, we'll draw that. All right, so this is isosceles trapezoid, which means this is parallel to this, and this is congruent to that, okay? I want to prove that, okay? So we have J, which is negative A and 0, and we have K, which is A and 0, and we have H, which is B and C, and we have F, which is negative B and C. All right, so we want to prove that it's an isosceles trapezoid. Well, first off, let's prove that it's a trapezoid. Okay, to prove it's a trapezoid, I need to prove that segment FH is parallel to segment JK. So I want to find the slope of segment FH and the slope of segment JK. You say, I don't know what the letters for. Well, that's fine. The whole point about a coordinate proof is if it works for letters, it would work for any numbers that you plug in. All right. So FH, we have negative B and C, and we have positive B and C. Okay. Well, C minus C is 0 over negative 2B, so that's a slope of 0. And then down here we have negative A and 0 over A and 0, which again is 0 over negative 2A, which has to be equal to 0, okay? Therefore, this is equal to this, so therefore this is parallel to this, so that proves it's a trapezoid, okay? Now I want to prove it's isosceles. Well, bad news bears, okay? To prove it's isosceles, I need to prove that these two segments are congruent, which means I'm going to have to do the distance formula, okay? All right, that's going to be a little messy here. But you still got your picture in front of you, so I'm going to erase this, and we're going to do the distance formulas, okay? Which means we need to show that Fj is equal to Kh, okay? So the distance formula, difference in x value squared plus the difference in y value squared, difference in x value squared plus the difference in y value squared, okay? All right, so F we said was negative B and C, so this is negative B and C, and J we said was negative A and 0, so this is negative A and 0, and down here we've got K is A and 0, and H is B and C. Okay. All right. So negative times a negative is a positive. That's positive A. So that's actually A minus B squared, right? plus c minus 0 z, c squared. So it's the square root of a minus b squared over c squared. All right. A minus b squared is really the same thing as -1 times a minus b, right? That quantity squared, c minus 0 c. So a negative squared is 1, so I really still have a minus b squared plus c squared. All I have to do is show that this is the same as this, which means they are congruent, and therefore this is an isosceles trapezoid, right? Okay, you can pause or do whatever while I'm erasing and setting up. All right, 18. All right, 18. Triangle RST is equilateral. Okay. We have triangle RST. Okay. So this is equilateral, which means this is congruent, this is congruent, that. So how do I prove that? Well, sorry, bad news. Okay. You have to do 3 distance formulas. Okay. You're going to have to do 3 distance formulas. So I'll set you up and then you're going to finish it on your own. So basically, so you've got your picture. Ignore another telephone call. It's important that I'll leave a message. All right. So I need to find RS. I need to find ST. And I need to find RT. Okay. Difference in x value squared plus the difference in y value squared. Difference in x value squared. Plus the difference in y value squared. Difference in x value squared plus the difference in y value squared. Okay. All right. And then so what R was 0 and 0. That's very nice. So we got a 0, 0, and a 0, 0. What S is 2b and 0. So this is 2b and 0 and 2b and 0. And point T was b and b squared root of 3. So this is b squared root of 3, b squared root of 3. Okay. All right, so this is going to be what? 2b squared plus 0, right? Well, the square root of 2b squared is 2b, right? Okay. All right, down here, b minus 2b, which is negative b, right, squared, plus b squared 3 minus 0 is b squared 3, so that's b squared 3 squared, okay. And b minus 0 is b squared, and same thing, plus b squared 3 squared, okay. So we already said this was 2b. Negative b squared is b squared. B squared 3 squared would be 3b squared, which is 4b squared. Square root of 4b squared is 2b, okay. And this looks the same, so it's going to be the same. So they're all going to be 2b. All right, make sure you finish that. Show me finishing that. Show me good work. I'm not going to finish it for you. And let's look at the next one. All right, 19. You got to earn your money on 19. I'm not going to do 19 for you, but it says it's a rhombus. Okay, so if it's a rhombus, that means I have 4 congruent sides, which means bad news, bears. I have to do 4 distance formulas. Okay. So that's the setup. You're going to have to find the length of all 4 sides. Show me your work. Show me your reducing. Okay. All right, 20 and 21, that's for the honors kids. And they just give you the description. So you have to draw your own picture and then write your coordinate proof. All right, so that's where you earn your money. I've done most of it for you if you've been watching the video. So you've got, for the regular guys, you've got 1 to finish on your own. And for the honors, you have 3. And that's it again. Let me know about your questions and I will answer your questions. See ya.